I want to go over the 1.4a worksheet titled One-Sided Limits. And you're given a piecewise function, and you have to sketch the graph of the piecewise function. So we're going to go ahead and do that. So they give us the square root of 1 minus x squared in the domain from 0 to 1. They give us 1 in the domain from 1 to 2, and then 2 when x equals 2. So the question is, what does the square root of 1 minus x squared look like? And how would you do it without a graphing calculator? Let's say that this problem was a problem that you weren't able to use the graphing calculator. So how would you graph square root of 1 minus x squared? Now, one thing that I need you to understand is that when you're given a piecewise function right here, like square root of 1 minus x squared, this is like having y equals the square root of 1 minus x squared. So if you have y equals the square root of 1 minus x squared, and let's say we square both sides to have y squared equals 1 minus x squared, and then we add x squared to both sides, we have y squared plus x squared equals 1. And if I rearrange this a little like this, this is the equation for a circle with the center at 0, 0 and a radius of 1. So we're more or less looking at a circle that looks like this. Center at 0, 0 at the origin and a radius of 1. But according to our domain, we are only focusing on the domain from 0 to 1, so, and including 0. So if we're looking at the domain from 0 to 1, we're really only looking at that quarter circle there. But don't forget that we're not including 1. So we have an open circle there, and this one should be filled in. So now we're going to graph the center one, 1 in the interval or in the domain from 1 to 2. And just like with the square root of 1 minus x squared, this is the same as writing y equals 1. So this is an easy graph. It's just a horizontal line cutting through y equals 1. But we're only staying from the domain from 1 to 2. And now this domain includes 1, but not 2. So we have a filled in circle at 1, an open circle at 2. And then we pretty much have, when y equals 2, x equals 2. This is like having the point 2, comma 2. When x equals 2, y equals 2. So just put a point, plot the point 2, comma 2, and we're ready to answer the questions. And in class, you were doing all of your graphs on graph papers, so I do want this, I expect this graph to be on graph paper so that it's a nice, neat graph. So the first question is, it's asking for the domain and range. So if you notice, on the domain, we do the half circle, and then we have an open circle here. So we have an open point, but then this saves it. So this is okay. And we do the line. We have an open circle, but then this point saves it. So the domain is all x values from 0 to 2, including 0 and 2. And you can write it in inequality notation, interval notation, with brackets and parentheses. Well, in this case, you wouldn't have any parentheses. Now we're looking for the range, and it's the same idea as when we were looking for the domain, but now for the y values. Now if you notice, this is an open circle at y equals, or an open point at y equals 0. So at y equals 0, and then there's no point to save it. Like this point saved it for the domain, but not for the range. So it's not including 0. We follow the half circle. Then notice that nothing goes on between 1 and 2 for the domain. So there's nothing in here up until the y equals 2. So it goes from y equals 0 all the way to y equals 1, not including the 0, and then y equals 2. So make sure you exclude the 0 in your notation. Include the 2. Oh, include the 1. That should be a 1, not a 2. And then it jumps to y equals 2. Now part B, at what point C, if any, does the limit of f of x as x approaches C exist? And one helpful tip to answering this question is ask yourself, where will the limit not exist? So the limit as x approaches what C value will the limit not exist? So pause the video, think about that. Given this graph, where will the limit not exist? And hopefully you said that when at 1, at x equals 1, or if C were to equal 1, because the limit from the left does not equal the limit from the right. So the limit from the left approaches 0, and the limit from the right approaches 1. Hopefully you also said when C equals 0, because there is no limit to the left. There's no graph to the left of 0. So there's only graph to the right of 0. So that there only exists a limit from the right. Nothing from the left, because there's no graph to it. And the same idea when C equals 2. So when C equals 2, the same idea. There's no graph to the right of 2, so the limit as x approaches 2 from the right does not exist. Only the limit as x approaches 2 from the left, and that equals 1. But these are the three values, or the three C values where the limit would not exist. It'll definitely exist everywhere else on this graph. So any C value between 0 and 1, and any C value from 1 to 2. And we pretty much answered C and D. At what points does only the left-hand limit exist? And D, at what points does only the right-hand limit exist? And so I said that at 2, the limit did not exist because there is no right-sided limit. Okay, only a left-sided limit. So there's no graph to the right of it, only graph to the left of it at C equals 2. So when C equals 2, the limit, there is no right-handed limit. And we pretty much use the same idea for part D. At what point does only the right-hand limit exist? So again, I said at C equals 0, the limit did not exist because there's no left-handed limit. There's no graph to the left, only the right. So for this one, the left-handed limit exists, only right-handed limit. And that's number 3 from the worksheet.